In Chapter 10, we are going to learn all about conic sections. Now, Section 1, we are exploring conic sections, and we're going to figure out what each equation for each conic section looks like and some key features related to each conic section. So first of all, here's our definition of a conic section, which we talked about through our exploration. But a conic section is the different shapes formed by a double cone intersected with a plane. And we saw in our exploration our four conic sections are circles, ellipses, parabolas, and hyperbolas. Those are our four conic sections. Reminder, circles, you know what they look like. Ellipses, those are our ovals. Parabolas, those are U shapes. And hyperbolas kind of look like parabolas, but there's two parts. Oops, that was really crooked. It should be like one right on top of another. That's a little bit better. A little bit anyway. Now, again, we're going to see what each conic section looks like, what the graph looks like. Here's example 1. And I'm just going to do one of each type here. Graph x squared plus y squared equals 25. Well, just looking at this equation, maybe we don't really know what this looks like, and that's okay. It's one of our conic sections. We know what an equation looks like for a parabola. Parabola is like y equals x squared. So this one's not a parabola, but between circles, ellipses, and hyperbolas, we don't really know what each equation looks like. If we don't know what something looks like, how could we graph it? Well, we can make a table of values. And that's what I'm going to do here. Let's make a table of values. And I want to find some x and y values that would fit nicely with my x squared plus y squared equals 25. I noticed right away, if x was 0, 0 squared plus y squared is 25. Well, if y was 5, that works. I'll write it here. 0 squared plus 5 squared is 25. That works, because 0 plus 5, or 0 plus 25. That works. I could do 5, 0. 5 squared plus 0 squared. 25 plus 0. That works. And what else could we do? Well, after a little bit of thinking, maybe you'll figure out that 3, 4 works also, because 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. That works. And we could flip these around. 4 and 3. Now, are there any other ones that we can come up with? Well, let's look back at this first one, 0, 5. Y could be negative 5 also. Because if I take negative 5 squared, I still get 25. So this y value could be positive or negative. Same thing with this x value. Both my x and my y here. Both my x and my y here. Those could all be positive or negative. If I look at this one, negative 4 squared plus negative 3 squared, that's still 16 and that's still 9. That works too. Now, that's a pretty darn good list of some ordered pairs. Let's use those to graph. So I have the point 0, 5. and 0, negative 5. 5, 0, and negative 5, 0. Now this plus minus 3 plus or minus 4, there's a lot of stuff going on. I could have positive 3 and positive 4, positive 3 and negative 4, or negative 3, positive 4, negative 3, negative 4. And same thing here. I could have positive 4, positive 3, positive 4, negative 3, negative 4, positive 3, and negative 4, negative 3. And if you connect your dots, hopefully you will see the shape that we have is a circle. And that's not completely perfect, but it's pretty darn good. Now, a couple ways I know it's a circle, or the biggest way I know it's a circle, is that my radius is 5. The center is 0, I go out to 5 each direction. That's the biggest way I know this is a circle. Okay, and I'm going to write a couple other things on my little graph paper here about my circle. First of all, is it a function? No, it's not a function. It's not a function because my x value of 3, for example, has 2 y values to go along with it, 4 and negative 4. So it's not a function. You might also think the vertical line test, it doesn't pass. What do you think about lines of symmetry? Well, our circle has infinite lines of symmetry. Line of symmetry is where can we draw a line where it's the same on both sides? Any line that passes through the center is a line of symmetry. Okay, so again, any line passing through the center, infinite number of lines of symmetry. And then let's also talk domain and range. Now this is one of our favorite things to think about. So domain, we're talking about x values, the possible x values of a function or an equation, since this one's not a function. Our possible x values, well, the lowest x value we see is negative 5. The highest is 5. Everything else is between that. So we could write our domain as negative 5 is less than or equal to x, less than or equal to positive 5. And our range, we have the same situation going on. Our lowest y value is negative 5. Our highest y value is 5. The only difference is now it's y's instead of x's. All right. I guess some of the things I noticed looking at my equation here is that for our equation of our circle, because that's what this equation was, we had x was squared and y was squared. We had addition, and our coefficients in front of the x squared and the y squared are the same. So those are some things to notice as we move forward.